Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have x plus 2 the whole divided by square root of x square minus 1. So what we have been given is dy by dx and we've been asked to find y. My y is nothing but integral of the given expression. So let's write down what our y is. So that's my y. I notice that my y is not in a very simple format whose antiderivative I know from first principles. But when I take a closer look at y, I see that I have a linear expression in the numerator, which is my x plus 2, and I have a quadratic expression x square minus 1. But unlike the regular quadratic expressions, which are of the type ax square plus bx plus c, here I have the coefficient of x in the quadratic expression within the square root is a 0, right? So how do we go about solving this problem, right? So we have a quadratic expression in the denominator, and then we have a linear expression in the numerator. So in some of our earlier videos, the way we used to solve this is express the numerator in terms of the derivative of the quadratic expression, right? So what's the derivative of the quadratic expression here? It is d by dx of x square minus 1, right, which is 2x, right, and then we have an x plus 2 in the numerator, right? So it's not too difficult to express it that way, but for a change I'm going to apply a slightly different technique, right? Instead of expressing the numerator in terms of the derivative of the quadratic expression which is there in the denominator, since I have an x square minus 1 here, I'm going to directly jump to a trigonometric substitution and see what I get, right? So let's attempt that and see if we are able to solve the problem by directly doing a trigonometric substitution. I have an x square minus 1. I want to draw your attention to the trigonometric formula sine squared theta plus cos squared theta equals 1, or a secant squared theta minus tan squared theta equals 1, right? So the substitution that will work out here is x equals secant theta, right? Because I have an x square minus 1 inside the square root in the denominator, and I know that secant square theta minus 1 equals tan square theta, right? So let me do the substitution x equals secant theta, which means my dx equals secant theta tan theta d theta, right? So I have my x, I have my dx both in terms of theta. So what I do now is I go back to my y and I try and replace my x in terms of theta, right? So what is my x plus 2? My x plus 2 is nothing but a secant theta plus 2. And then my denominator, which is a square root of secant square theta minus 1, which is nothing but a square root of tan square theta, which is nothing but a tan theta, right? Right, and then I have my dx. We have our dx as well. What is our dx? It's nothing but a secant theta tan theta d theta, right? So what happens next is I notice that I have a tan theta in the numerator, I have a tan theta in the denominator. So I can remove the tan theta here and I can re-express my y as follows, right? So I get a 2 plus secant theta times secant theta d theta, right? So what happens now is I can apply the sum rule of integral and I can rewrite this as integral of 2 secant theta d theta, 2 being a constant, I can move it out of the integral. And then I come to the second part, which is nothing but an integral of secant squared theta d theta, right? So there we are. Now solving this from here on is not very difficult, and we have learnt in our earlier videos how to go about solving integral of secant theta d theta, and I'll also give a link to that particular video in the description where we have solved for integral of secant x dx, right? And what is that? It is nothing but log of mod of secant theta plus tan theta, right? And then let's come to the second part, which is very simple because my integral of secant squared theta d theta is nothing but a tan theta, right? Why is that? Because my d by d theta of tan theta is a secant squared theta, right? So now we have the answer, but then we have it in terms of theta. So we'll have to put back everything in terms of x, right? So what is that original substitution that we made? The substitution that we made was x equals secant theta. So it's not too difficult. My secant theta is x. My tan theta is root of secant squared theta minus 1, which means that I get a root of x squared minus 1. So that's my part 1. And then I come to my part 2, which is again a tan theta, which is nothing but your square root of x square minus 1, which we just now worked out, right? And then I have my constant c. So the answer to this problem is 2 times log of mod of x plus root of x square minus 1 plus square root of x square minus 1 plus c. And remember that the expression inside the log is within the mod, right? So let me highlight my final answer in pink. So there we are. I hope you found my video useful. Please do subscribe to my channel and support. Thank you.